Okay, so we've had another look. We've had a look at one of my sets today, which is a kind of one I bought as a new set that is a return and sold on from a well-known retailer, and it does have complex faults. So I'm going to skip that and get back on with one of Julian's. It's 1st of May. Be able to shout Mayday. Rumour has it this is a Mustang 3000. Standard replacement Palmer coffin mic. Must have been like Christmas wrapping all these sets up. Oh, it's come with some bits of bracket for me to lose. And 3 thumb screws. Wing nuts. We had a teacher at school we called Wing Nut. Wonder why. So it's lost its irreplaceable connector, because it's the it's that little side thing which other sets which use this chassis, such as the Amstrad, use. You know, all we can do is kind of tidy that up probably for him and put a fuse holder on, which is a shame. They were, you couldn't get them even by the December that they were sold in the November. You know, it was, which is of course why they moved on to the other type of connector, the square and round one. So Mustang 3000. Right, and the serial number with the other glasses, 03595. Switch it on, channel 20, picture in picture, and what have we got? Nothing, because I haven't plugged the aerial in. Right, what we've got? 3.45. I've got a monitor receiver on from the job which you haven't yet seen. Channel 40, 3.4, channel 1, 3.5. Low power. Actually, find it. Two tools on the floor. Select channel 20, and we have 210 milliwatts. Go back to normal power, and we have current draw of 1482, which is high. We'll take deviation with a pinch of salt because the meter's not right on here, but then sometimes it is. Just tune it for wallow. It looks like it's right today. Wallow. It's 3. But I'll have to verify that on another meter. Just putting it in the wrong box. Test set's been on for ages, like hours, and so whatever it says is the frequencies will be true-ish. 27,79141. So it's a bit high, which is good because the crystals can drop. So receive 2779. It matches well what the radio's on. Where's RF gain? Not at full. Delta tune to center. Cyanide meter on, and plug the cyanide meter in to the radio. Let's go over to cyanide meter and see what it has to say. Poltergeist has moved the camera. Sounds like this detector's a bit out, to be honest. So for 12 dB, just check my switches are in the right position. Yes, they are. Oh, actually, we're doing very well. We've got 0.39. For 10 dB, we've got 0.31. For 20 dB, it'll do it. It won't do it at all. It will. This tells me the detector's out. It's 1.7 millivolts. Full squelch. It's 30 millivolts, 30 microvolts, so that could do with coming up a bit. We'll turn the signal generator to standby, set the threshold on the radio, switch the signal generator back on. It's 0.32. Press transmit and the meter says what? It should be in the middle of the red zone. It says high. Put 100 microvolts on the signal generator and the receive meter says, well, it's not like that. We'd set it like this, don't we? It's there. It is not a million miles out. It's 37 microvolts. We'll come back to that. Right, let's get it opened up. It's so heavy I couldn't lift it. Nice dent in the case. Pray there's no silliness. No, it's got the right resistor. Good. I'm going to come back to the VCO. We normally do it first, but yeah, I'll get Mr. Chippie to improve that. Not a lot we can do, but hopefully can improve it and put a bit of a grommet there and a bit of a strain relief. Right, channel 20. Fix Roger bleep. Get the tool off the floor. Put the soldering on to warm up because I need to melt the wax. Just move on to deviation, and if we can believe this instrument at the moment, wallow. One, two, wallow. Looks right, but I'll verify with another one. Wallow. It's too quiet now. Wallow. Get it there eventually. Wallow. You know what? It's now too quiet. It's just hovering between. Try that. Wallow. Looks about right. Anyway, we're going to verify that on another deviation meter. Right, soldering iron should be warmed up enough. Now I've just got to look for misplaced coils, but to be honest, they look right. If it's low on power, the thing to do is to very slightly change the ballast resistor, which is I think what we're going to do. Yeah, it all looks pretty tidy. That is already at full, so it's only doing 3.5 watts, and of course it should be doing 4. So we'll get on with that. So that is the right resistor, but it could just do with, I think it's 3.3 ohms. We'll just pop that down to 3. Right, we'll have another go at retuning it. So we've gone from 3.3 ohms 3 watt resistor to a 3 ohm 6 watt resistor. Although they're similar, they're identical size, those are 3 watt. Right, let's have a look at the meter now. No doubt we'll have to turn it down. Let's turn the set on, that would help. Four watts bang on. That's it. There's nothing spare. It's 4 watts on channel 20, but it's come up half a watt for a change of a 68 pence part, and that can only be good, I am sure. You may get an extra 100 yards range. Where's my pen gone? It's 4 watts on channel 20. Let's have a look at the other channels. 3.9 watts on channel 40. And 3.95 watts on channel 1, which is nice and balanced. Low power, faff about with that little switch, is now 270 milliwatts. So it's not adjustable, but it's come up in sympathy. Our transmit current back in high power. Well, that was a flawed test. It was on channel 20. It was on channel 1. Just try again. Yeah, 270 milliwatts. Yeah. So back in high power, our current consumption is now 1.468. 1.468. So we've gained half a watt, and the power consumption has marginally dropped, which is what a retune can do. Let's go through the VCO. Just prove to myself it's a negative chassis. It is. So far side of the capacitor. Yeah, right, here we go. I have to get the instructions every single time using the Amstrad manual. These rarely work out as it says in the manual. So we'll do channel 1. Start on channel 1. Channel 1 receive. So it should be 2 volts. We're just going to drop it that absolute tiny bit. Well, it'll never work out, it never does, but as long as it's in lock. And on transmit, it's 2.3. Trimmer there for transmit. They recommend using a dummy microphone plug which is wired to permanently transmit, and you can see why, because you're fiddling about with holding probes on. I think we've got a dirty preset there. So 2.0 something. Check receive is still somewhere near. It is. Channel 40. Supposed to be around 4 to 5 volts. Well, it's 3.5, and on transmit it's 3.3, and that's about where you expect it to be. The manual is not correct on that, and one of the failings in the manual is it doesn't tell you with what instrument they've got that figure. Is it an AVO 8? Probably is, you see, and I'm using a digital meter. So back in the day they needed to specify what kind of instrument you were using. But I've checked it, it's in lock, and that's what it's about. So we've now done the transmitter. We're going to do the deviation. We've done the deviation. We're going to do the meter. It's banging across. It should be in the centre of the red zone. It's the preset just there. that is the centre of the red zone. I'm going to check the radio in PA mode. Testing 1 2, testing 1 2, testing 1 2, 1 2, 1 2. It works. It was 2.2, it's now 2.0. Frequency, are we going to adjust that? I want it to stay a little bit high. Let's go to the camera. Nine 125. Just drop it to because they drop with age. Well, I'll just leave it that little bit high. So 27 79129. Right, so let's move on to the receiver. Now it just sounds a bit harsh to me, so that's usually the detector bit out. Let's go over to the oscilloscope. Tell you, poltergeist moving these cameras. It looks harsh and nasty. Can't remember whether it's that one or that one. I'm just going to check my deviation on this test set. It's 1.5. Normally you have your deviation about 1.4 on your test set. They're calling for 1.25 on this radio. So I'm going to oblige. There we are. Reset the deviation. Although you're going to be transmitting as high as 2.5 kilohertz, you'd be saturating the detector, so this is why you have it at a lower level. That still doesn't tell me where we are. We are doing what? It's over the page, no wonder I can't find it. Transformer 11. Which is the upper one. Well, I'll tell you what, it's spot on. So in that case, the IF sound. So we'll deal with that next. Still distort. We'll go to the cyanide meter. We'll do the normal tune-up. It's being affected by the delta tune. That's what the problem is. So what we'll do that again. There we go. Now we'll go for the cyanide meter. These are well tuned. You know, all the used sets he's brought, the receive's been very good. That's it. So for 12 dB, well, it was 12 dB a second ago. dB, we've got 0.42. No, we haven't. 0.4. With 10 dB, got 0.34. 20 dB, we've now got 2.4. So you'll see that's come down absolutely massively from right up beyond, but at the sensitive end it looks like it's worse, but that's because it was distorted. So we can also, let's go back to 12. We can fiddle with the delta tune. So there we are on 0.4. I'm going to fiddle with the delta tune. You can see how you can move the cyanide around. We can also fiddle with the tone control. And that will also change the cyanide. So, good result. Really sensitive set. That squelch control could do with some switch. Not did I say tone control? I think it could probably all do with some. Good. Right, we need to set S9 on the meter. So 100 microvolts on the meter, and the preset is there. Checking the RF gains at full. Yes, it is. So that's another thing done. Now it's a squelch. Just could do with going up a fraction. So I'll turn the squelch to full. We'll squelch out 30 microvolts. We've squelched out 100 microvolts too. That's it. That's 100. Excellent. Let's go over to the attenuator and you can see what we're doing. So now we'll redo the squelch sensitivity test, put the signal generator to standby, turn the squelch down on the radio, set the threshold on the radio, switch the signal generator back on, and what we've now got. It's opening at 0.55. So it's 0.55, and at tight it's 100 microvolts. That's now set to 100 microvolts. That's 100 microvolts. That's set center of red zone, which is correct. Switches work, we've dealt with that. tone control, clean, sockets work, PA works. So I'm just going to verify on another deviation meter where we are with the deviation. It looks right on this one, but I need to prove it, because these sets can end up with 15 kilohertz deviation if you're not careful. So let's just unplug that, plug that in. Socket. The socket needs tightening. We're going to do it on the air test. We're going to come back to it after the on the air test. We're going to sort out that there, put a fuse holder in it, and we'll also solder up that a bit tighter. So I'm going to put the lids on loosely for the on the air test and kill that moth, which should probably come out of my wallet. Right, let's just plug the dummy load into the other deviation meter. Go to transmit, turn the volume down. Wallow. Yes, miles too high. So it was wrong. Wallow. Now it's too quiet. Let's try that. Wallow. Bit too quiet. Wallow, wallow. There we go. We're also going to test it on a third deviation meter. Which is the one built into the quartz lock 282A test set on the bench behind me. This is a deviation meter I never trust, which is why I want 3 opinions. Wallow, wallow. Wallow. Let's listen to what it sounds like. Testing 1 2, testing 1 2 3 4 5 5 4 3 2 1. 1 2 1 2. Yes, I think we're about where it should be. I hate it when this happens. Good. Well, that's it. We will put the set together. Right, so to conclude, I was just double checking the deviation. The phone rang. It's my good friend Mark, ZX2 G7N DJ. He's coming to stay the weekend, so we will be having some radio fun. Alright, we've got the air along it. We've got the mic twazzled round its own lead. Oh. Because I've got one hand holding the radio. Right, see how many bad buddies are on. One Nano Roger. Roger. There's some distant racket. Oh, it's music playing, which you the kind of thing you'd expect. Oh, somebody's out there. Right. Well, we'll do an on-the-air test. We're going to do that very shortly, like in 10 minutes. And then I'll pass this set on for Mr. Chippie just to do something better with the power lead and the antenna socket. So thanks for watching. Hope you were pleased to see this very nice Mustang 3000 get another lease of life with a retune and bringing it up from 3.5 to the 4 watts.